Now let's discuss the situation. If fx is square root of x, gx equals -2 times f 3x plus 15 plus 4. Here, we need to observe this is the base function. So first, we can graph the function of x. Here, this is the graph of this function, that you say the base function, the graph. Now, if we want to transform this function to this final transformed function, we need to observe the relation between this function and this function. Here, inside the brackets, we have 3x plus 15. So, we need to guarantee, first, here, this x, if we assume the x, the specific value, x0, that you say, next, we need to guarantee the whole inside the bracket, 3x plus 15 equals the specific value of x0. So the relationship between the x and this x0 should be like this. 3x equals x0 minus 15. X equals x0 over 3 minus 5. So this is the relationship between x0 and this x. That you say, if you want to guarantee this whole equals x0, x must be equal to x0 over 3, then minus 5. So if we have known the graph of this function, it is this green graph. If we want to guarantee this f 3x plus 15 equals this calculation, we need to guarantee x equals this number over 3, then minus 5. So for this graph, if we want to guarantee this square root of x0 keeps unchanged, the corresponding x-coordinate should be x0 over 3. Then, every point on this graph, we do this same transformation, we can get this corresponding graph of this function. And on the basis of this function, we want to get this function that you say f 3x plus 15. So we need to guarantee this x plus 5 equals any x0, 3x plus 5 equals 3x0. That you say, we need to compare this function and this function. So for every x0, here it should be 3x0 square root sine, then this should be equals this one. So this part equals this part. X plus 5 equals x0. So x equals x0 minus 5. That you say every point on this graph, we need to move this point to the left side by 5 units. 5 units, 5 units, 5 units, 5 units. So OA, this distance should be equal to 5. Then we can get the corresponding graph of this function. It should be the yellow curve. Okay, that you say this x should be on the basis of this specific value, first divided by 3, then for the same y value, we need to move this point to the left side by 5 units. So we can locate the original point. Its image point on this graph should be here. Okay. Similarly, we can locate the other points first here, then move to the left side by 5 units. Then we can get this graph for this function. Okay. On the basis of this function, you can easily understand we just need to amplify the corresponding y-coordinate by 2 as the factor, so we can get the corresponding graph of this function. That you say here, this y-coordinate equals 0, so times 2 still equals 0. So this point still itself, but this point, if the y-coordinate is amplified by 2, it should be here. Similarly, we can get the corresponding for every point on this graph, then we can get this graph. On the basis of this one, we can reflect this graph over x-axis. That you say, we reflect this graph over x-axis, we can get this corresponding graph of this function. Okay, on the basis of this function, it is just like negative 2 times f 3x plus 15. On the basis of this function, at 4, it means we just need to move the graph of this function upwards by 4 units. This point, if it is moved upwards here, so PA should be equal to 4. The distance between these 2 points, the distance also equal to 4. This point and this point, this distance also equal to 4. Then on the basis of this function, if we translate the graph upwards, we can get this function's graph. It should be here. Okay, now let's summarize the method if we want to transform this function to this function. Here we must do some change for this expression. First, we need to isolate 3 from the bracket. So inside the bracket, it should be 5. Okay, it is just like this one. K is 3, x k equal to 3, x is x, minus d equal to plus 5. So here d should be negative 5. Here, it is just like C. Okay, first before this, we need to consider this negative 2. It is just like this A. So A equal to negative 2 plus C. That is say, on the basis of this expression at C. If C greater than 0, it is just like here, 4 greater than 0. So plus C meaning plus 4 in this example. This is the transformation from this base function to the transformed function. First, you must be careful. Here, 3 should not be just the coefficient of x. It should be the coefficient of bracket x minus d. Outside of the bracket, k should be the coefficient, not just the coefficient of x. It should be the coefficient of x minus d. Okay, then outside of the function, the coefficient should be a. On the basis of this expression at C, we can get the transformed function.